Hello friends, welcome to another video of Infinity Infopedia. Today we are going to talk about the universe and its wonders. And just like me, I'm sure the biggest wonder of universe which amazed you is black holes. Don't let the name fool you. A black hole is anything but empty space. Rather, it's a great amount of matter packed into a very small area. Think of a star 10 times more massive than the sun, squeezed into a sphere approximately the diameter of New York City. The result is a gravitational field so strong that nothing, not even light, can escape. So come, let's try to understand these aspects and the reality of black holes in today's video. Black hole remained largely unknown until the 20th century. A black hole is a region in space where the force of gravity is so strong not even light can escape. From the outside, you can't tell what is inside a black hole. Black holes haunt our universe, dark centers of gravity that swallow everything in their path. Let's begin with the beginning of the story, friends. The history of black holes isn't very long. 100 years ago, no one knew about black holes. Because of Einstein's theory of relativity, black holes were later discovered. Friends, there are two parts of the theory: the special theory of relativity and the general theory of relativity. The special theory of relativity, published by Einstein in 1905, tells us how speed influences time. If you are in a spaceship that is going very fast, if the speed is too high, time will slow down for you, relative to the people not on the spaceship, back on Earth. The word relative is very important because when you are in a spaceship, you wouldn't feel the time slowing down. You would think that time is flowing at the same speed as it normally does. But when you will get back to the Earth, you will find out that there was a difference in the flow of time. Not only speed, but even gravity can also result in time dilation, as shown by the Einstein in his general theory of relativity. This was developed by him in 1915. The more gravitational force you would experience, the more time would slow down for you. This is known as gravitational time dilation. To visualize this, Einstein wanted us to imagine a space-time fabric, kind of like a mesh on which all planetary objects are placed. The space-time fabric bends due to the mass of the objects. And when the mesh bends, not only does it attract physical objects more, but it leads to time dilation as well, and the other forms of energy such as sound, heat or light. Yup, that's right. This was another conclusion drawn by Einstein. Gravitation affects almost everything. Friends, this means that there can be such objects in this universe which have such a high gravitational force that they can completely absorb light. If there are such objects, it means that they would be completely black. We won't be able to see them, because not even light can escape them. This is exactly what black holes are. But when Einstein presented his theory of general relativity, the concept of black holes was merely theoretical back then. Einstein knew that gravitation influences light, and theoretically, objects that can absorb light were possible. But Einstein didn't know that there are actual black holes. By the time he passed away, not even the term black hole was invented. An interesting fun fact here: a key point in Einstein theory was that light's speed limits gravity's influence. We don't feel gravity's force instantly everywhere. Its upper limit is the speed of light. To use a practical example, suppose that the sun disappeared suddenly. As you know, we will get to know this 8 minutes later on Earth about the disappearance, because it takes 8 minutes for sunlight to reach Earth. But according to Einstein, the gravitational impact of the sun's disappearance will also be felt 8 minutes later. Isn't it very interesting? After Einstein, the theory of general relativity was worked on by many scientists. They solved many questions and tried to derive the solutions. And it was theoretically proven that things like black holes do indeed exist. By the 1960s, researchers and scientists had finally agreed that not only theoretically, perhaps one day, realistically, we would be able to see black holes, because these do exist in space. The term black hole was used for the first time by a magazine in 1964, but only after 1967 did the term gain popularity when physicist John Wheeler popularized it. Even though the term black hole sounds quite sensational, it is a misleading name. Black hole. It might sound like there is an actual hole there, but that's not the case. There is no hole in space. Black holes are formed by stars. In the stars, even our sun is a star, there is a continuous nuclear fusion reaction in their centers. These reactions produce heat and light. The heat being produced sends a force outwards, and at the center of the star, there is the force of gravity. This helps the star remain intact and alive. This is how the stars maintain equilibrium throughout their lives. The forces pushing outwards due to a reaction and the forces pulling inwards due to the gravity. But these reactions take place when a fuel exists, either hydrogen or helium. The fuel wouldn't always be there. It would get burned up at some point. And when the fuel ends, there wouldn't be any forces pushing outwards. And the gravitational force pulling inwards wouldn't be countered by an equal force. So that star will collapse on itself because of its own gravity. This will take a long time, by the way. Our sun's life expectancy is around 10 billion years. But what happens next depends on the mass of the star. Let's look at the chart of life cycle of a star. If the mass of the star isn't high, if it was a small or average sized star, it turns into a red giant. But if it was a huge star, a star with a lot of mass, when it runs out of fuel, it cools down and turns into a red supergiant. And then the supergiant bursts and turns into a supernova. After this, a tiny core remains. If the core is tiny, it is called a neutron star. But anything bigger than that, we call it a black hole. Basically speaking, the mass of the star after it collapses due to its gravitational force becomes small and condensed, and it can turn into a black hole. For a star as big as our sun, if that turns into a black hole, the diameter of that black hole will be merely 50 kilometers. There are mainly 3 to 4 types of black holes, friends. The first is the stellar black hole. That is the most common type of black hole. The black holes that were created by stars. Scientists estimate that in our Milky Way galaxy, there are anywhere between 10 million to 1 billion such black holes. Then there are the primordial black holes. These black holes are as small as an atom, but their mass is like that of a mountain. The third type of black hole is the supermassive black hole. These black holes are enormous, so big that their mass is more than that of 1 million suns combined. And it fits into a ball whose diameter is as big as that of our solar system. Scientists believe that at the center of every major galaxy, there is a supermassive black hole. Additionally, scientists believe that there may be a fourth type of black hole too. Though it cannot be said for sure, the fourth type of black hole will be intermediate black hole. That lies somewhere between the size of stellar and supermassive black holes, although no proof of it has been discovered yet. The black hole isn't like a big black ball that sucks everything around it. The black holes look somewhat like this. There is an orange colored ring that forms around the black hole. It is known as the accretion disk. It is an important feature of black holes. As you know, the gravitational pull in black holes is very high. So due to the gravitational pull, a lot of gaseous matter is attracted towards the black hole and remains floating all around it. Similar to how the planets revolve around the sun because of the sun's gravitational force. The difference is that the gravitational pull of black holes is so strong that the things revolving around it revolves at a very high speed and gets so heated up that they turn into a flowing fluid-like matter. They literally become fire-like particles that are hotter than 1,000,000 degrees Celsius. The closer they get to the black hole, the faster they revolve around it. The particles revolve so fast that they get rubbed together and compressed. This causes them to start glowing. They emit electromagnetic radiations, which are mainly X-rays. In 2019, the first photo of a black hole was taken. The things that we have seen for sure about black hole is this single photo. This photo taken by the Event Horizon Telescope on 10th April 2019. This proved the existence of black holes practically, about 100 years after they were proven theoretically. One thing is sure here, if you fall into a black hole, the chances are that you will disintegrate into pieces due to the gravitational force. You will die in milliseconds. But even so, friends, there is no need to be scared of black holes. Earlier, many people had this misconception that the black holes suck up all matter, keep getting bigger, and eventually it will end the whole universe. But that's not how it works. As I told you, at the center of each galaxy, there is a supermassive black hole, and all other planetary bodies and stars in the range of the black hole revolve around it, in the same way that all planets in our solar system revolve around the sun. As a conclusion, if you maintain a proper distance from a black hole, you will be safe and secure. Black holes are not as soporific as they seem from the name. That's all for now. If you like this video, hit the like button and subscribe our channel for more such interesting videos. Thank you for watching.